Thank you. Welcome. So today we will, me and my friend, we are going to walk through the logic or the concept of what is the concept behind the slope of a line. We all know that the slope of the line is given by the equation y is equal to mx plus c. Okay. If you know why this is so, then this video is not for you. But if not, then please listen in. We'll try to demystify why is the slope of a line y is equal to mx plus c. Okay, now go to this. So line going through the origin. Imagine a line going through an origin. So what is the slope? Okay, we'll get into the line of the equation itself, but what is the slope given a line that goes to the origin? Or any, I mean, a line, even if it doesn't go through, it will have a slope. But let's pick a line that actually goes through the origin, and let's see what the slope of this line is. And my friend here, like, I do want to ask him the question, what do you think is the slope of this line? You there? Hello?
Yeah, I'm here, but I can't see. Somehow this is not showing me the full screen. Okay, there you go. I think
these are grids. Like, can you see the grids there? You should be able to see the grids, right?
Yeah, I see the grid. Okay, yeah.
So using the grids, what is the slope of this line?
Slope. So what is the slope?
The slope is, let's see, given x is equal to y, what is the slope of this line? Actually, here is the actual definition of the slope. Slope is rise over run. Okay, so in this case, the angle is there, and m is the slope. M is a ratio, and that's a ratio of the y over given a x, what is the corresponding y? So in this case, there are 3 units of the run and there are 3 units of the rise. Okay, so you calculate the slope is equal to however many, like whatever the distance of the rise over the distance of the run. So in this case, you can say that the distance of the rise is 3 and the run also 3. So it's 3 by 3, the slope is 1.
Yeah, okay.
So given this, so this is what it is. So it's like the slope is 1. Okay, especially when the angle is 45 degrees, the slope is going to be 1. Okay, but again, how is the slope? How do you get the slope? It's dividing the corresponding, given a value of x from the origin, and then what is the value of y from the origin? You divide y over x. Okay, so given, now let me ask a question, right? Given x is equal to 5, what is y in this picture? So this is point for 1, 2, 3, 4, and 5. Okay. So what's the value of y? Okay.
5.
1, 2, 3, 4, 5.
5.
So it's 5. And the slope. So when you know, so you do, now that you know the value of 5. Okay. Now let's say 10. You don't need a graph of 10 points, right?
Yeah.
To figure out the value of y.
That's
you know this, the slope is 1, so you can plug in x, you should get the y. Okay, in this case, this, yeah, so that's what it is. Now what is the slope of this line?
So if x is 1, y is like kind of 0.5.
Okay, or you can say when x is 2, what is y?
Y is 1.
1. Yeah. So the slope is equal to the rise over run, 1 over 2.
1 over 2, yeah.
So and then we can write that equation m is equal to y by x, right? Y by x. and because the slope is rise over run, and you can say y is equal to 2x, or sorry, y is equal, m is equal to y by x, so y by y is, yeah, y is it, no, that's not right.
mx, y equal to mx.
Y is equal to mx, and m is half in this case, so y is equal to half of x. So that makes sense. So let's say given a value of 4, y is equal to half of 4, and then you plug it in, y is equal to 2. So
yeah, y equal to
yeah. So given a value of x, you multiply it by the slope, you get the value of y. Okay, that's good. What is the slope of this line? Now you can same thing, like given x is equal to 2, what is y?
Yeah, okay, y equal to half of 2 is 1.
Yeah, and so same thing, right? So given x and the slope, how do you get y? So okay, now let's go to the you like the equation of the line is y is equal to mx.
Yeah.
Especially is if the line is going through the origin. So the green line, you look at this green line is going through the origin, and the equation of that is y is equal to mx. The slope is obviously like the m is half, so half of x, and then you get the equation. So any point you take, any x point, you can get the corresponding y point, and that y point will be on the green line. Okay, that is how we are able to say that, oh, this is the this is the line, or y, yeah, that is the equation of this particular line, right? So given any x, I can figure out the value of y, and that point is on this line, right? Now my question is, what about this choice line? What do you think is the equation for that line?
So if x is 1, or in this case, like y is kind of 1, 2.5, x is 2, y is 2.
Like, let's start, like which point were you
3.
thinking? Which
2.
x were you thinking?
Like x is 2,
X is
then
2.
y is 3.
Y is 3. But how did you get y is 3? Given a slope, okay? Given a slope and x, can you figure out this y is equal to 3?
Given a slope and x, I can figure out y. Yeah.
How do you figure out?
Because y equal to mx, right?
On the green line, for the green line, you can figure out the point, right?
Yeah.
Given x, say x is 2, you get like this point right here is y is equal to mx, and then you're getting this as like m is half, right? M is 1 by 2. So y is equal to half of x, and that's why you're getting this point as, like, when given x is equal to 2, you get y as 1, right? But I don't want you to, yeah, I know you know now to get the points on this green line, but given x, say x is 2, yeah, you get this y is 1, but I want you to get y is equal to 3. How will you get y is equal to 3 now? Or given x is equal to 4, you can compute by using y is equal to mx, y is 2, right? Y is 2. Given x is equal to 4, y is 2. But I want you to get y is equal to 4. How will you get that?
4, yeah. But it varies, right? Like wherever that slope, whatever the line, the angle changes, then the slope will be different though.
Yes, that is correct. But given this slope, given this, like the slope is half. So if you notice the turquoise line and the green line, they are of the same slope, right? So how will you?
Okay, but the green line is going through the horizon though. That's the difference, right?
That's the difference, correct. So since it's going through the origin, if a line is going through origin, your life is easy, like y is equal to mx. You can easily say it. But what about this turquoise line? And the turquoise line and this green line, they are parallel. The only difference between these two lines is that the green line is going through the origin.
Yeah.
So how do you connect this turquoise line and the green line? So let's say I give x is equal to, let's say x is equal
3.
to 10. X
Okay.
is 10. What is the value of the green line?
Y equal to 5.
Yeah. What does that mean, that that point for the turquoise, and what would that be then?
Turquoise, I don't know
Okay,
the value. Yeah.
let's take this 2, right?
1, 2, 2.
2, and I got this. I get, so first I compute the green value, okay?
Yeah, that is 1. Yep.
That is 1. And then all I have to do is I'm going up 2 points, and then I will get this 3.
Mm-hmm.
Okay. Then if I'm x is equal to 4, y is equal to 2, and then I just have to go up 2 points, and then I land on the blue line or the turquoise line.
Mm-hmm.
What about x is equal to 6? So y is equal to half of 6, x is equal to 3. Yeah, we see that x is equal to 3. That is the green line. That's the point on the green line. To get the point on the turquoise, what I do?
Yeah, 2 more. Yeah.
2 more. So
Yeah.
that means, so what is the equation of this line, the
Okay.
turquoise?
We are adding plus something to
And
that
what is that
mx.
plus something?
Is it the difference between the green line and the turquoise line?
Yes. And what is the difference?
In this case, it's 2.
It's 2. Where do you see that 2? How do you decipher that 2? Where did you get that 2 there?
Yeah, I have a question though. Like if x is 1, 2, 1, 2, 3, right? If x is 3, so how do we go and like measure for y, like for turquoise line?
Okay. So first you measure this green line, right? Y
Yeah.
is equal to half of 3, 1.5. And then again, I go, what's the distance between these two lines? It's just 2, right? I just go 2 points up.
Okay. Yeah.
3.5.
Oh, that is a constant. Basically, wherever you go, it's constant.
Yeah. So it's 2. In this case, it's 2.
Yeah.
Where is it that, how do you know that it is actually the difference between these two, the y's are 2? How do you know that?
How do you know meaning?
How did you get it? Is why is it not 3 or why is it not 1?
No, the difference, right? We travel from the green to turquoise and see the difference.
Okay, where is it that, how do you decipher? Yeah, it's, you measure the distance here, but that distance, you can see it, we can compute it easily by looking at this point here, right?
Yeah,
This turquoise is going through, this is the y-axis,
from the
and it is,
horizon to that.
yeah, so this is called as, this point is called as the intercept, y-intercept of the turquoise line.
Okay, got it. So from the horizon. So that
So
difference is 2. So anywhere you go, it will be 2. Okay,
it
if
will
it is
be 2.
parallel line.
Yeah. So that's why the equation of the line is, right?
Mx
So
plus c.
given a slope m and an x, or now, okay, so this is, that's why the equation of a slope is y is equal to mx plus whatever its intercept you have.
Okay, got it. Yeah, awesome.
Okay.
Yeah.
Now comes the kicker. Usually the trend is to provide the y-intercept. Okay, they will say this is the y-intercept. It's called as the labeled as c, you know. So that's why it's like y is equal to mx. Y is equal to mx gives the line through the origin, and then they will do the plus c. Okay, if this turquoise line was, say, it was in the negative side, -2, right? The intercept is -2. So y is equal to mx plus c. But instead of c, when c is -2, they substitute -2. It's basically, when you do minus, it moves the line downwards by 2 points. And that's what you can have -10, -5, whatever, or you can even plus. So when you're doing y is equal to mx, what then plus something, that plus whatever units is the amount of units you're taking this line through the origin, and you're moving up by that many points. You got that. Now I'm saying, let's say we question the convention. Instead of okay, y is equal, they provide the y-intercept. Now let's flip that, okay? Let's try to see what if the mathematicians or the community, the global world, instead of giving the C, let's say we are given a B, okay? Let's say, uh, in this case, we are giving it as a B is the intercept of a line of the x-axis. Then we're not, so in this case, if you look at it, the intercept of the y-axis is 1, but they didn't give 1. They just said, hey, it's intercepting the x-axis at 2. How would you now, how would you say, how would you find the value of y now? Or y is equal to what? As a, yeah. How would you do that? So given a slope m and an x-intercept, what is the equation of a line?
We don't have x.
We can pull any point, right? Let's if we put 2, it'll be 0 because it's going through this. The red line is going through the 0. Y is 0. When x is 2, y is 0. When x is say 4, y is 1 here in this case, right? So yeah, it is there, but instead of usually the way they do is they give a slope and they give this value of 1 for the y-intercept, and you will go ahead, y is equal to mx plus c. You know, there is that y is like the slope is there. The slope in this case is half, right? Like you saw that, right? And then when you given a value of what do you call when the value of c x is equal to 2, and then y is equal to mx plus c, right? Mx is like half of x is 1, and then the c is minus 1. So you are actually doing 1 minus 1, and you get a y is equal to 0. You get that. So the y is equal to mx. If you're given this y-intercept, it works. But I've given you the x-intercept. I've given you the x-intercept as 2. If you're given the x-intercept as 2, how will you now figure out the equation of this line? What is the relationship between x and y? How will you go about it? It's a hard one, right?
No, when you say x-intercept, you said like you gave x-intercept, right? So if you go back to the previous slide, or like wherever it is, right? These examples. So this has y. How do I know I have y?
So given a point, right? Given a point, and then I just do m.
Yeah, okay, rise by run, and you get the y point.
That's how you get the point, yeah. Because this line is going through the origin, I know that if I multiply x and m, I get y. So here the critical question is this, right? Instead of usually, yeah. So here it's the other way around. Instead of you getting y and then adding or this one, now you have x-intercept. So what do you do to? So here I'll give a clue. Try to leverage your knowledge about this green line that's going through the origin, right?
Yeah.
There m is that where m is equal to 1 by 2. You can clearly see that the slope of the line is there, is like from there you can see it's 1 by 2.
Yeah, m is 1 by 2. Yeah.
So given the x, how do you land on this green line to begin with?
So y equal to mx, right?
Y is equal to mx is the equation of given
green. Yeah. So if you want to get x equal to y by m, so 2y, x equal to 2y.
X is equal to 2y. X is equal to, how do you say that x is equal to 2 times y? Why would you say that?
1 second, maybe I'm telling wrong. So y equal to mx. So we need x equal to y by m, right? X equal to y by m, then y and m we know all have. So it will be 2y, x equal to 2y.
Okay. But x is equal to 2y is okay. M is equal to half. Y is equal to no, y is equal to mx. Y is equal to 1 by 2x. X is equal to 2y. Yes, that is correct. X is equal to 2y. But usually in an equation, you input x to get y. So what do you do? So given, let's say, given this x is equal to 2, I want y is, yeah, so y is 1, right? In this case, it's 1. So let's say x is equal to, say, 6. Y is equal to, I want to commit as 2. How will you do that? Yeah. So what do you, okay, so if we know that what is that? Y is equal to mx for this green line, right? So if for the green line that's going through the origin, the equation of a line is, you can say y is equal to mx. So given the x on this, on the red line, or given, or for given a point, that's, well, not the point, but yeah, given a point, given a point on the x line, on the red line, if we have to move it, if it has to merge onto the green line, what do you have to do? The red line, if it has to become, like, merge onto this green line, what should you do?
Whatever the difference, we need to take the difference out.
Where right? Is the difference? Where is the difference? That's the question.
The difference between that green and the red line, like.
Okay. What's the unit? What's the unit of difference there?
Negative. I mean,
it's negative. It's negative, but what's the unit? Okay, what's the value?
Value
in terms of y, the difference is 1, right? It's -1, like, negative, like, yeah. It's actually, you can say, like, you have to, if you add 1 to the y, it will merge it into the blue, into the green line. But if in terms of the x value, you have to, you're saying negative, means, like, what is that? What do you have to do for the x term of this equation to get to green line? If it has to merge into, if it has to become the green line, what operation do you do on this x, on the red line? So this point here, right? If it has to merge onto green point, the green line, it has to move how many points to the left? Maybe I'm complicating this.
No. When you say x, right? Let's say you have 1, 2, this 2. X, right? That is there. So you want to move this to this top, right? You want to be overlapping each other, or
yeah, overlap. Yeah, I want it to overlap. I want to basically merge into this green line. So it's like,
yeah, merge into, right? Like, move those many points. It's like parallel line. So wherever you take, whatever the difference is, it will be the same across those two lines, right?
Okay. And you can so because you're given an x-intercept, you just minus the x minus 2. When you take whatever point you give on this line, you do -2, you will come to this, you will come onto the, you will be on the green line.
Why -2?
No, x minus any point to, okay, let's take this point here. Okay, this is 4. Okay, 4. X is 4, y is 1. Okay, for this that's the point you can say is x comma y. It is 4 comma 1, 4 comma 1. Okay, x is 4, y is 1. Now, to what is the coordinate of this point? 2 comma 1. Maybe I should write it, but
yeah, that's fine. I got it. Okay.
Yeah, so it's 2 comma 1. So any point you take the x part and -2, you come here.
Why I need to go there?
Because once you get onto this line, you can use that y is equal to mx. So given an x, you can find y. Maybe I'm, yeah. Y given,
okay, I see.
y is equal to mx, right? So now what is the actual? So for the red line, whatever x you have, you do a minus 2, and then you can do y is equal to mx. So that is what should, so like, so here we say m is equal to y by x minus b, or y m into x or y is equal to m into x minus b. So that's how you were able to get the point, the y is equal to m
Okay,
into.
okay, the difference. Okay.
So that's
Intercept. Okay, okay.
So we are using a different concept, but still trying to you. But in this case, it is this b is the y, the x-intercept, not the y-intercept. But usually the mathematicians, as a convention, they use the y-intercept as the they give us so yeah, y is equal to mx, right? This one, the the coordinate of x will be the slope, and then the plus c always represents the y-intercept.
Yeah.
If it
I
goes to the
intercept.
origin, c is 0, or then if it goes through negative, then it's below the x-axis or whatever. But the general convention is the intercept of the y. They don't use the intercept on the x, but this was to mainly to give you an idea as to what type of
Okay, okay.
transformation you can do to get to.
Yeah.
Let me stop the recording now.